Okay, thank you very much and welcome back. This is the second webinar of our AG-WaMED Masterclass, and I'm very happy to leave the floor for Professor Mohamed Bahanassi from Alexandria University in Egypt, one of the partners of AG-WaMED project, for his contribution about the tool of the living labs in our project and more in general within the framework of PRIMA program. Thanks a lot.
Good morning, everybody. I'm glad to be among you in this activity, the second webinar organized by the AG-WaMED project that's funded by PRIMA Foundation. The project entitled Advancing Non-Conventional Water Management for Innovative Climate Resilient Water Governance in the Mediterranean area. Today's topic is about living lab approach for managing Mediterranean water resource. And actually, we have developed a living lab methodology that is applied in the first participatory workshop for collecting information and reaching to the ideas and thinking of the stakeholders participating in the project. Today we will talk about the living labs and their aims, types and examples of living labs and elements of living labs, the components, and we will talk about the living lab approach from the point of view of benefits and the challenges and the methods of involving a stakeholder in the living lab. Then we will talk rapidly about the non-conventional water definition and challenges. Of course, Professor Preshi gave a very detailed overview about the non-conventional water, so this one will be a very quick overview. And then we will talk about creating living lab, and we will provide you with the experience of Alexandria University, how we developed our living lab and what are the different activities involved in doing that. What is a living lab? A living lab is a user-centered, open innovation environment that involves different stakeholders in co-creating, exploring, experimenting, and evaluating innovative ideas, scenarios, concepts, and related technological artifacts in real life setting. So we are dealing with a living or live area, which includes all the people who are living in this area and the physical context of this area. So we call it a living lab. Living labs can be applied to various domains, such as health, culture, mobility, smart cities, energy, education, and government, as well as other disciplines. So the name is not coincide to water resource management. It's open and anyone can apply living lab. Living labs use various methods and tools to involve users and stakeholders in all stages of the innovation lifecycle, from design to evaluation. Also, they can use ICT, information communication technology, and infrastructure to support data collection, communication, collaboration, prototyping, and testing. So we are utilizing the innovation or the new technologies represented by information communication technology, the internet, the computers, and all this stuff in order to communicate between each other. Elements of living labs, we can have many elements of the living lab, and the first one is active user involvement. This is crucial to the living lab. Means empowering end users to thoroughly impact the innovation process. So we should have the end users, we ask them about their opinions, and also sometimes we ask them about their experience. We transfer experience between each other. The second element is that the living lab is real life setting, which means testing and experiment with new artifacts. The second element is that the living lab should have multi-stakeholder participation. This is very important, which means involving technology providers, service providers, relevant institutional actors, professional or residential end users. So this is very important that we have diverse stakeholder participation. And stakeholder participation and the presence is vital for the living labs. The fourth element is that the living lab should have a multi-method approach, which means the combination of methods and tools originating from ethnography, psychology, sociology, strategic management, and engineering, and other disciplines. So this is very important that we have a mix of approaches and methods. The fifth element is that co-creation, which means iterations of design cycles with different sets of stakeholders. This is very important because the co-concept is that involving the stakeholders in every action we are doing. This is very important. We should ask them what we are going to do. We should ask them what we have done. We should ask them about their opinions, and we should ask them if what we have done is suitable for them. All this stuff are very important. Now we are talking about types, drivers, and examples of the living lab. The first type, we call it utilizer-driven living lab. Here we can find the main driver is an organization that utilizes the outcome of the innovation process. Example, a company, public authority, an NGO, non-governmental organization. All these are examples of utilizers who can take advantage of the living lab. The second type, we call it enabler-driven living lab. The main driver here is an organization that enables or facilitates the innovation process, like a university or research institute. So these two examples enable the process of innovation. The third type, provider-driven living labs. The main driver is an organization that provides the resources or infrastructure for the innovation process. Examples, technology provider, platform provider, network provider. So this type of living lab is mainly concentrated on the information and communication technology providers. The fourth type, user-driven living lab. And the main driver here is a group of users or community that participates in the innovation process, like citizens, consumers, and professionals. And what we are dealing is a user-driven living lab. This is what we are developing and involving because, the user here is the center of our attention, the end user. So what are the components of the living lab? The components of the living labs are the essential elements that enable them to function as open innovation ecosystem in a real-life environment. These components are interrelated and interdependent on each other, and they may vary depending on the specific objectives, scope, and context of each living lab. The first component is the approach. And by approach, we mean the methodology and principles that guide the living lab activities, such as user involvement, co-creation, experimentation, and evaluation. All these are different types of approaches in co-creation, experimentation, evaluation, and user involvement. So these are the different approaches. The approach should be flexible, iterative, and adapted to the specific context and needs of the stakeholder. So the first component is the approach. ICT and infrastructure, information communication technology. This refers to the technological tools and platforms that support the living lab process, such as data collection, communication, collaboration, prototyping, and testing. The ICT and infrastructure should be reliable, secure, and user-friendly. The third component is the management and refers to the organizational and operational aspects of the living lab, such as governance, coordination, funding, and risk management. The management should be transparent, efficient, and effective. The next component is the partners and users. And this refers to the actors and stakeholders that participate in the living lab activities, such as researchers, companies, public authorities, civil society organizations, and end users. The partners and users should be diverse, representative, and engaged. The last component is the research, which refers to the scientific and academic outcomes of the living lab activities, such as publications, reports, models, and frameworks. The research should be rigorous, relevant, and impactful. Now we look at the living lab approach, which is user-centered, open innovation ecosystem that involves different stakeholders in co-creating, exploring, experimenting, evaluating innovative ideas, scenarios, concepts, and so on. We have some benefits of the living lab approach. The first one is that it allows for more holistic understanding of the user needs, references, and context. The second benefit is that fosters the collaboration and the trust among the participants and enhances their sense of ownership and empowerment. Enables rapid prototyping and testing of solutions in realistic environment and with real feedback. Facilitates the scaling up and the diffusion of innovations and businesses across different domains and regions. There are some challenges for the living lab approach. The first one, it requires a high level of commitment and coordination among the partners and stakeholders. This is very important. Coordination and commitment. Involves ethical, legal, and social issues related to the collection, privacy, security, and context. Demands flexible and adaptive management of the innovation process and the evaluation of outcomes. It poses methodological and technical difficulties in capturing, analyzing, and integrating complex and diverse data. The methods used for involving the stakeholders in the living labs are different. The first one is structured interaction. And it means methods that follow a predefined format or protocol, such as workshops, focus group, interviews, surveys. Second method for involving stakeholders in the living lab is flexible interaction. And these are methods that allow for spontaneous and informal communication, such as social media, online platform, chatbots, etc. Third method is extended network, and these are methods that leverage existing network or create new one to reach out the potential users and stakeholders, such as snowball sampling, crowdsourcing, intermediaries, etc. Fourth method is special actors. And these are the methods that involve specific actors who can play a key role in the innovation process, such as lead users, ambassadors, champions, etc. Learning and engaging. And these methods that aim to increase the knowledge and innovation of users and stakeholders, such as gamification, storytelling, training sessions, etc. Design approaches, and these are methods that apply design thinking or participatory design principles to involve users and stakeholders in the co-creation of the solution, such as prototyping, co-design, workshops, and scenarios. The seventh method is the techniques, which are tools or techniques to facilitate user and stakeholder involvement, such as observation, brainstorming, affinity diagramming, etc. The last method is operational guidelines, and these are methods that provide guidance or frameworks for planning and implementing user and stakeholder involvement, such as stakeholder analysis, user journey mapping, evaluation criteria, etc. So these are the different methods that could be applied, sometimes most of them, sometimes one of them, for involving the stakeholders in the living lab. Now we talk about non-conventional water. I will not go in detail, but just simple idea. Non-conventional water is a water that is generated as a byproduct of specialized process or that needs suitable pre-use treatment or management. Some examples of the main non-conventional waters are recycled water, and these are waters that has been treated after being used for domestic, industrial, or agricultural purposes, and that can be reused for various applications, such as irrigation, landscaping, toilet flushing, etc. Another type of non-conventional water is a desalinated water. And this is water that has been obtained from the seawater or brackish water by removing salts and other that can be used for drinking, cooking, and other domestic uses. Stormwater is water that runs off from surfaces such as roofs, roads, or fields during or after a rainfall event that can be collected and stored for irrigation, groundwater recharging, or other purposes. Another type of non-conventional water is agricultural drainage water. And this water drains from the agricultural fields after irrigation or rainfall. And that can be reused for irrigation after treatment or blending with fresh water. Thermoelectric cooling water, and this water is used to cool down the steam generated by thermoelectric power plants, and that can be reused for irrigation and other industrial uses after treatment. Hydraulic fracturing water, another type, and this water is injected into the underground rock formations to extract natural gas or oil, and that can be reused for hydraulic fracturing or other industrial uses after treatment. So it will be reused for the same purpose. Another type is the industrial processed water, and this is water that's used in various industrial processes such as manufacturing, mining, or refining, and that can be reused after industrial or agriculture uses after treatment. Hot spring water, and this water that emerges from the ground at high temperatures due to geothermal activity, and that can be used for heating, passing, and other processes. Now we look at the challenges to water management, and the first and most important one is water scarcity and drought. The Mediterranean region is one of the most water-stressed regions, as Professor Reishi has indicated in her presentation, with an average annual renewable water availability of 1,100 cubic meter per capita. And this is well below the water scarcity threshold of 1,700 cubic meter per capita. Climate change is expected to exacerbate this situation by reducing precipitation, increasing evapotranspiration. Droughts are frequent and severe in many parts of the region, affecting agriculture, urban water supply, energy production, and ecosystem. The second challenge is the water quality degradation. This is very important because the Mediterranean region suffers from various sources of water pollution, such as untreated wastewater, agricultural runoff, industrial effluents, solid waste, marine litter. Water quality degradation affects human health, aquatic life, tourism, and recreation. It also reduces the availability of freshwater resources for different uses and increases the cost of water treatment. Another challenge is the water allocation and use conflict. The increasing demand for water from different sectors like agriculture, industry, and domestic, and users either urban or rural, creates competition and conflicts over water resources. Lack of adequate legal and institutional framework, participatory mechanism, and transparent information system. Another challenge is water governance and policy. This is very important. Why? Because water scarcity, climate change, and socio-economic development affects water policies. Water governance and policy need to be improved by strengthening the coordination and integration of different levels, like local level, national level, and regional level. Sectors, creation of different sectors like water, agriculture, energy, environment. Integration of different stakeholders like public, private, and civil society. Sound scientific knowledge, reliable data, and innovation tools are a must requirement. So it should be involved. Now we go in detail to see how are we going to create a living lab, and we will give you the experience of Alexandria University after creating the living lab methodology, which are the set of methods that would be used in the living lab, and the implementation of the first participatory workshop with the stakeholders to see how things are going. To create a living lab, you need to follow some steps that can be vary, be different, depending on the context and the goals of the project. However, the general framework can be summarized as follows. First step, locate the study site. So it's very important to see, okay, we will work in this area and define the biophysical and socio-economic characteristics based on previous studies and researches. So this is the first step, is to locate, determine what is the site, where are the area you are going to apply the living lab. The second step, identify the problem or challenge that you want to address with the living lab approach. This can be done by conducting a situational analysis, engaging with potential users and stakeholders, and defining the scope and objectives of the project. The third step is to establish a living lab network that consists of core team, the partners, and the end users who will participate in the innovation process. The network should be diverse, representative, and collaborative, and should have clear roles and responsibilities. The next step is a design and plan the living lab activities that will involve the co-creation, prototyping, testing, and evaluation of solutions. The activities should be based on user needs and feedback and should use various methods and tools to facilitate participation and learning. Step number 4 is implement and monitor the living lab activities according to the plan. This implementation should be flexible, adaptive to changing circumstances and user inputs. The monitoring should collect data and evidence on the process and outcomes of the activity, using both quantitative and qualitative indicators. The last step is to evaluate and communicate the results and impacts of the living lab project. The evaluation should assess the effectiveness, efficiency, relevance, sustainability, and scalability of the solution. Communication should disseminate the findings of the lesson learned to relevant audiences and stakeholders. The second step is to follow the RRI methodology, responsible research and innovation. What is responsible research and innovation? It is a term used by EU, European Union framework programs, to describe scientific research and technological development processes that take into account effects and potential impacts on the environment and society. So it's very important that we include both the environment and the society. It stresses the societal challenges should be a primary focus of scientific research. RRI involves holding research to high ethical standards, ensuring gender equality, engaging the communities affected by innovation, ensuring that they have the knowledge necessary to understand the implications. We have 8 steps in performing the RRI. We call it RRI roadmap. And these steps are going through transition stages as illustrated in the figure, where each phase reaches one RRI roadmap milestone. The milestones and their steps guide the transition process to identify the needs, motivate change, engage, ideate, and frame, co-design, co-construct, and implement solutions, measure them, and adjust them, and intensify. This will ensure viable, sustainable, and worthwhile actions toward solutions that are created and accepted by most stakeholders. In each of these phases. The third step, we should carry what we called it best leak analysis. So what's best leak analysis? P stands for policy, E stands for economic, S stands for social, T stands for technological, L stands for legal, first E stands for environmental, second E stands for ethical, and C stands for citizen science. For this type of analysis, we see each factor related to each category. For example, policy and political issues, we see policy directive, policy trends, bureaucracy, international relationships, corruption. So these all are the points or factors that should be described for the study side or the living lab. Economic empowerment, employment, consumer confidence, seasonality, wage rate, labor force, economic policies. These are some examples for the factors that should be included in the analysis. For the social part, we study level of education, gender equality and gender issues, local energy demand, demographics, and other factors. For the technological aspects, we concentrate on technological innovations and technological factors. For legal part, in industry regulation, competition regulation, taxation, safety regulation, and other factors. For the environment, we look at the environmental protection regulations, waste management, protecting biodiversity, use and risk of pesticides and fertilizers, climate change, natural resources. So these are some of the factors that should be considered when studying or experimenting the environmental category. The ethical part should concentrate on the social inclusion, lack of respect, different types of discrimination, morality, integrity, behavior, social responsibility, and negligence. For the citizen science stakeholders interaction, we use mutual collaboration, understanding, transfer of knowledge, methods, data, and procedures among the actors. So these are the points that best leak analysis is concentrating. The next step, based on the analysis, best leak analysis, we perform SWOT analysis. And SWOT analysis concentrate on strengths, weaknesses, opportunities, and threats that are characterizing the living lab. For example, the strengths, we look at the advantages, capabilities, resource assets, people, marketing, reach, distribution, awareness. So these are the factors or the points of the strengths factor. What are the weaknesses present in the living lab? What are the opportunities that we expect to achieve? And what are the threats that hinder the implementation of the living lab? The next step is to build stakeholder list. And this is some of the stakeholders that are present in the living lab area. Some of them are local, some of them are national, some of them are scientific, some belong to industry, so it should be diverse. And the list of stakeholders we gather, we make analysis of stakeholders. For each stakeholder, we see what are the different characteristics. For example, sector, type, level of influence, level of interest, type. So we gather all this information about stakeholders. Order for the next step, we concentrate on two characteristics. The first one is influence, and the second one interest, in order to carry out the stakeholder mapping. Stakeholder mapping depends on the interest of the stakeholder in the living lab and living lab characteristics and ideas and challenges and their influence on the stakeholder, on the living lab. So we take care of these two characteristics, interest and influence, in order to map the stakeholders into one of four groups. Group A has high influence, low interest. This is influence from low to high, interest from low to high. So this group, we call it keep satisfied. The second group, which has high influence and high interest, we call it manage closely. And this is the most important group of stakeholders that will affect the living lab. The third group, we call it a group with low influence and low interest. And for this one, we should keep monitoring this type of stakeholders. The last group of stakeholders, which has low influence but has high interest of the project objectives and challenges, we call it keep informing. Okay, so these are the four parts of the four categories of the stakeholder mapping. Keep satisfied, manage closely, monitor, and keep informed. So based on this one, the stakeholders, yeah. Can you hear me? Can you hear me?
Yes, Professor, we can hear you. Please go ahead.
So the stakeholders we are dealing with should satisfy the quantable helix model or QH model. So this means that the stakeholders should represent 5 subsystems. Academia, so some stakeholders should come from the academia, industry, government, society, and environment. So we should have 5 types of stakeholders that should be included in the stakeholder list and stakeholder analysis and stakeholder mapping. This is very important. And we can see from the figure below that we have 5 helix. And actually, I am explaining the development of the QH model because it started with triple helix, only 3 different types of stakeholders belonging to academia, industry, and government. And then quadruple helix, so they added society, because the research done in the past was excluding the society and stakeholders from the process. Quadruple helix added the society component, and then the quintuple helix QH has added the environment. So it's very important to see the impact of our research on the environment. This is very important. So in order to engage the stakeholder and collect useful information from them, we use a methodology called World Cafe. And the World Cafe is a method that collects data from the stakeholders using specific type of organization. For example, we organize stakeholders into groups, and each group is sitting on a table, and the number of stakeholders per table should be 4 or 5, should not increase more than 6. So 4 to 5 is a good number. So the organization is that each World Cafe should have a facilitator, a person who is going to explain the ideas, the challenges, and tell story about the study area or the living lab. And the second group is the facilitator assistants, people who are running the computer, taking care of the presentation, all this stuff. And each table should have a host, and the host is the person that will manage the conversation between the stakeholders and ask them questions, collect data from them. Also, there should be a photographer to take photographs of the event, the participants, and the groups of rounding tables. So we can see in the figure, we have 6 groups of rounding tables. So this number is not fixed. Can have 5 tables, 4 tables, depending on the challenges that are going to discuss. The World Cafe should be or should have a comfortable setting. Means that the participants are sitting in a place which is very comfortable. Have good lighting, clean, all this stuff. And the participants getting to know each other and discuss idea knowledge and then getting ideas. We should develop storytelling and we should develop a triggering question that the World Cafe will be built on. For example, for the storytelling, we should talk about climate. We should talk about available water resources. We should talk about energy resources, farming systems, climate change and its effects, such as farmers are pushed in debt and even selling their assets because, the climate has affects the people, the living lab adversely. There is no rainfall, people getting poor.
Professor Banassi, I'm sorry. Can you please reach the conclusion so we allocate some time for the question, like 15 minutes?
Yeah, I will finish in 5 minutes. Policy to import food, which increase even more local procedure and local policies. The triggering question, for example, how could we utilize non-conventional water resources to overcome climate changes occurring in the area? This is pictures from the first living lab, participatory living lab, and here we are collecting the information from the stakeholders and then voting for the results that we obtain, and then we develop a findings of the Thank you. Can you hear me?
Professor, thank you for the very interesting presentation. If there are questions, as previously, please type them in the chat and we will read them for Professor Banassi. So we have a question. Monji Ben Zayed is asking if asking the difference between compoundments, so researchers and users, and stakeholders involved in the live event. I don't know if Professor can answer, and or if Monji Ben Zayed can detail more the question, so Professor can answer better.
I don't know. It seems that I have problem with the. Yeah.
Thank you, Professor, for the presentation, and thank you, organizers, for the organizing of this master class. My question at the beginning of the presentation, Professor Muhammad speak about the different compounds, and one of them is the researchers and user and other compoundment. And what is the main difference between this compoundment and the stakeholder involved at the scale of living lab?
Okay, the end users are the stakeholders who are going to implement the findings of the living lab. Researchers are the professors and the university people who are going to conduct the research, taking into consideration different ideas from the stakeholders. So I guess this is the difference between researchers and stakeholders. These are going to do something, and these are going to do something. And both of them are component of the QH model, because researchers belong to academia, end users are people living in the or staying in the living lab. Okay.
Thank you.
Thank you, Professor Banassi. If there aren't any other questions, we do a small break up to 11:30. Thank you, everybody.
Thank you.